Hello, good morning. This is Shakti Ganesh, Assistant Professor, School of Computer Science and Engineering, VIT University-Chennai. This is a video lecture on Advanced Software Engineering and the course code is CSE 502. The outline of lecture is we are going to discuss about software cost estimation and we are going to see the two approaches. One is the older approach which is known as LOC estimation, and the newer approach is known as function point analysis. We'll be discussing the problems and solutions over it. The first one is a software cost estimation. The task of software cost estimation is to determine how many resources are needed to complete the project. There are two very different approaches. To cost estimation. One is the older approach, which is called as LOC estimation, and the newer approach is called function point analysis. The older approach, which is known as LOC estimation, the older approach is called LOC estimation, since it is based on initial estimation, the number of lines of code that will need to develop for the project. We'll be counting the number of lines, that's a valid lines which is useful for the code, and we'll be counting the lines of code and we'll estimate the project. And the new approach is by finding the function point analysis, by finding the adjacent factor, and we'll be seeing the outer elements of the projects. And we'll be dividing the components into simple, average and complex. Based upon this, we'll be finding the function point analysis of the project and we'll be estimating the cost of the project. The older approach is LOC estimation. The first step in LOC based estimation is to estimate the number of lines of code in a finished project. This can be done based on experience. And second one is size of the previous project, size of the competitor solution, or by breaking down the project into smaller pieces and then estimating the size of each of the smaller pieces. So what we'll do is we'll divide the project into so many pieces, like the best guess, minimum, max of the project, and we'll be doing the standard deviation of it, and we'll find the better element of the project by calculating the lines of code. A standard approach is for each pieces will be divided as pieces known as pieces of I. To estimate the maximum possible size is denoted by max of I, and the minimum possible size is min of I. The best guess size denoted by best of I. The estimate for the whole project is 1/6 of sum of max and the minimum, and 4 times of the best guess. So we'll do the addition of 1/6 of sum of maximum plus minimum plus 4 into the best guess. So we'll divide the project into so many components. One is maximum elements of the project, minimum elements of the project, and best guess of the project. This can be done by the experience as well as by lines of code or from comparing between the existing projects. The formula is standard deviation is SD, which is SD square plus SD square plus SD square whole power 1 by 2. Then SD of summation of I is max minus min. So this is the sample example. Or suppose Team X had identified 7 subpieces to their project with the estimate of size of each subpieces. So the subpiece size might be like we are divided into 7 parts. One is max size, min, best guess, and min size. So we'll divide it into 7 parts. Part 1 is max size is 20, best case is 30, and minimum size is 50. And part 2 is max size is 10, best case is 15, minimum size is 25. And part 3, max size is 25, best case is 30, and minimum size is 45. And part 4, the maximum size is 30, best case is 35, and minimum is 40. And part 5, the max size is 15, the best case is 20, and the minimum size is 25. And part 6, the max size is 10, the best case is 12, the minimum size is 14. And part 7, the max size is 20, the best case is 22, the minimum size is 25. This is divided by the whole project. The project is divided into max, min, and the best case. So we'll divide the project into so many pieces. We call it as a work breakdown structure. We'll divide the project into so many sub pieces, and these pieces is calculated in the different format like max size, min size, and best case based upon the accumulated best fit values. And this can be done by the comparison of the previous projects or by calculating the LOC or by dividing the project into so many pieces. So the estimate for each sections are as follows. Like we'll divide into P1 part 1 the formula will be implemented as max plus best case 4 into best case plus min divided by 6. So for the part 1 it is 190 divided by 6, that will be 31.6, and part 2 is 95 divided by 6, that will be 15.8, and part 3 is 190 by 6, it is equal to 13.6, and part 4 it is 220 by 6, that is equal to 36.7, and part 5 it is 120 divided by 6, that is equal to 20, and part 6 it is 72 by 6, that is equal to 12, and part 7 it is 133 divided by 6, that is equal to 22.17. So we'll divide all the components into so many sub pieces like part 1, part 2, part 3, part 4, part 5, part 6, part 7, and based upon this we'll be submitting some values by calculating the standard deviation of it. So the estimate for the whole project is sum of estimate for each section. So the whole we'll calculate it, and the whole project is 170.07 LOC. So this is how the older approach works by calculating the lines of code. The estimate for standard deviation for the estimate of the following is SD. The formula is SD square minus SD square the whole power 2. So for the first one is max minus min the whole square plus max minus min whole square of part 2, max minus min the whole square of part 3, max minus min the whole square of part 4, and as follows. So it divided into whole power 1 by 2. So it will come around 900 plus 225 plus 400 plus 100 plus 100 plus 16 plus 25 the whole power 1 by 2. That is equal to 1766 whole power 1 by 2. That is equal to 42.07. So the entire LOC for the particular project based upon the work breakdown structure, it is 42.03. So this is how the LOC is calculated. From the LOC we will be finding the cost estimation of the whole project. This is how the older approach works. And the new approach is function point analysis. It is designed to estimate the measure, the time, and therefore the cost of developing new software application, maintaining existing software application. It is also used in comparing and highlighting opportunities for productivity improvements in software development. How the function point analysis is done? Working from the project design specification, the following system functions are measured. Like once we have found a project, we will be finding the inputs, outputs, files, inquiries, and interface. So we divide the project into these many factors. One is inputs, outputs, files, inquiries, and interface. So these function point counts are weighted and multiplied by the degrees of complexity. So we'll find the degree of complexity and we'll sum it into like simple, complex, and average. So we'll found that some components of the inputs will be on simple, some components of output will be on average, and some components of files will be on complex. So we'll divide the category into 3 sectors. One is simple, average, and complex. This is a sample problem. Calculating the adjacent function point for the project which has the below requirement, like which has 4 inputs, which is divided into 1 simple, 2 average, and 1 complex. And we have other 6 outputs in this, which is divided into 1 simple, 3 average, and 2 complex, and 8 files are remaining simple 0, average 0, and it has 8 complex factors. So 13 queries, 18 simple, 12 complex, and we have 0 average, and 8 interfaces, 6 simple and 2 complex, and 0 average. And the below listed environment factors influence the project. So these environment factors which influence the factors in various sectors. So environment factor like data communication, distributed computing, performance requirement, constraints, transaction rate, online inquiries, end user efficiency, online updates, complex processing, reusability, ease of conversation, ease of operation, use of multiple sites, potential for function change. So these are the environment factors which affect the project. And based upon this, we will prioritize into high, below average, low, and average. And we have a reference table over it. By this, we will calculate the adjacent factor too. So these are reference table. This is the initial reference table based upon the experience from previous projects. We have manipulated this reference table. For the reference table for degree of complexity, for inputs is 4, 4, 6. output is 357, files is 51515, inquiry is 246, interface is 41010. And again the reference table for adjacent factors, when it is not considered, we will put it as 0. When it is low, we will consider as 1. When it is below average, we will take it as 2. When it is average, we will take it as 3. When it is above average, we will take it as 4. And when it is high, it is 5. So based upon this, we will do the math. Like we have 4 inputs, we will take the reference table for simple, average and complex, and we'll multiply it, and we'll do a total of it. So similarly we'll do for the other files, inquiries, outputs, interfaces also. So at last we'll get the analysis function point as 3222 by overall summation of it. Next is environment factor. Based upon the reference table, low, average, when it is not considered it is 0, when it is low it is 1, when it is below average it is 2. So by seeing the reference table, we'll be map the values, and we'll be, by totaling it, we'll get the adjacent factor as 48. So we'll have a common formula for adjacent function point, that is equal to analysis function point into 0.65. 0.65 is calculated from the Z value table by comparing so many projects, and we'll put a value as 0.65, and adjacent factor into 0.01. Again 0.01 is a reference value which is taken from so many projects. So by comparing, they have finalized that 0.01. So that is equal to 332, which is a analysis function point by calculating the simple, average, complex, and 0.65 is a constant value. Again 48 is adjacent factor, again 0.0 is constant value. So by multiplying, we will get 363.86 adjacent function. So this is the other method of calculating the cost estimation. Now we'll do the total cost estimation, but how long will the project take, how much will it cost? As previous measure, on the average, organized average, we have 18 function points per month. So thus 363 function point divided by 18 will give 20 man per month. So if the average program paid, it's average paid cost. So it's $5,200 per month. So it is 20 man into $5,200. It is 1,04,000. So by this we'll give the cost estimation of the employee salary. By this we'll adjust other environment factors, and we'll total it, and we'll find the overall cost estimation. So this session ends about saying the two different approach. One is older approach, other one is newer approach, by finding the cost estimation. The older approach states that how it will calculate by calculating the lines of code. The new approach using the so many formulas and constant values by dividing the factors like simple, complex and average, and doing it, and by finding the adjacent factors, we'll find the overall cost estimation of the project. Right. So next session will be on work breakdown structure, how work breakdown structure works, and based upon the work breakdown, what are the advantages of this one. We'll continue in the next class. Thank you. For any queries, please mail me shaktiganesh.m@vit.ac.in. Thank you.